Okay, hello and welcome back to Chapter 7 Notes. And so now we continue on by talking about a few qualitative considerations in decision making and also talking about the utilization of constrained resources. So finally, we were talking about here those common allocated fixed costs. Those are not incremental. So remember what we were talking about before is we had that art department and they were allocating their costs out like this. And remember what we said is you got $10, so that 2.5 goes here, like this. Okay? And so we said if you drop magazine 1, then this comes over here. So when we talk about this thing called the common allocation death spiral, sounds like something out of Star Wars, if we drop magazine 1, and then magazine 2, magazine 3, and magazine 4 now get a bigger share of the art department costs. And of course, we're assuming that the $10 of art department costs will stay the same. Now, there could be a case to be made that the art department has lost 25% of its internal business, and so why are you keeping headcount and your costs staying the same? That is a legitimate issue that should be dealt with. But in the context that we're assuming right now is that this stays the same. So then the art department's cost just gets shifted to other product lines. In that case, what you could have is a situation where now magazine 2 looks unprofitable because it now receives a larger share of those allocated common fixed costs. And that's what this is kind of talking about. You just need to understand and be aware of that issue. Okay? There are some qualitative considerations that we need to think about in terms of decisions. Examples would be employee morale. If you drop a product line, a lot of employees could be very nervous about their future jobs. Legal issues, if you were to outsource maybe some sensitive government contracts to another country, that may cause some legal issues. Company reputation, if you were to outsource American jobs to another country, that could cause some issues with your company reputation. And of course, just layoffs, you don't want your name splashed the company's name all over the Wall Street Journal making layoffs. It just doesn't look good for the general public sometimes. Of course, and what we're assuming so far is that the quality of service and the quality of the product was the same with that outsourcing decision, and that may not be the case. And so that also needs to be figured into your decision-making criteria, okay? So now let's talk about utilization of a constrained resource. So before we even talk about that, we're going to talk briefly, very high level, about the theory of constraints. But I won't talk about it too much because you will have an article that you have to read talking about the theory of constraints and how it applies to healthcare. But let's go ahead and define a constraint here. A constraint is anything that prevents an organization from getting more of what it wants. So maybe what you have is a particular machine only has enough time to process one product or to make one product and then not make the other product. It can only make one product or the other product, and so which product should you make? Or maybe it only has enough time to make product A and part of product B. And so you have to figure out how you divide up this time. Okay? And so when we think about constraints from a personal standpoint, we all have the constraint of time. So we only have so many hours in the day, and we need to think about what's the priority. What things do we need to do first? And so that's kind of like what we're talking about over here and discussing our utilization of a constrained resource. So getting back to that idea of that machine not having enough time, if we don't have enough capacity on the machine, for example, and that will be the example that we work with in this product, which products should we focus on? Well, what we want to do is we're going to maximize our total contribution margin, which is our sales minus our variable cost, by emphasizing the products that have the highest contribution margin per unit of the constrained resource. So what this is like is, let's say that your time is your constraint, and you have two part-time jobs. You have part-time job A that pays you $15 an hour, and you have part-time job B that pays you $10 an hour. Which one are you going to do? You're going to put as many hours to part-time job A because it pays you more per hour. And then any other time that you have left over, you will then go to the second part-time job. Okay, so that's kind of the same thing. What are we doing in that situation? You're maximizing your wage per hour. In this case, what we're trying to do is figuring out which products give us the highest contribution margin per unit, or in the case of a machine, per minute on the machine, which gives us the highest contribution margin per minute on the machine, okay, in the context of a machine. So we can talk about, one thing we can also talk about with regard to constraints is the theory of constraints. And so when we look down here, I'm going to focus down here, look at the steps in the theory of constraints. The first thing that we would do is identify the constraint. So we have some process or piece of equipment or machine that is not keeping up. It's slowing down our production process. I remember I used to go to Subway a lot to get a sub, for lunch, and sometimes it would take a long time. And I noticed that the thing that was holding it up is when they asked people, customers, do you want your sub toasted? He said, well, yeah, I want it toasted. A lot of people want it toasted. Well, they only had one oven. And so what would happen is they would all have to wait, all the sandwich makers would have to wait in line to use the oven. I think the oven would take about a minute to toast it. So then you have this long line, and why did the line of customers start to grow longer? Because all these sandwich makers were trying to use that same toaster. And so what they eventually did was bought another toaster. And so then the line started to go faster, because what did they do? They identified the constraint, which was that toaster. And then they started to try to break that constraint by in this case, adding a second toaster. So when you think more about the steps in the theory of constraints, we're going to identify the constraint, which in the case of Subway was that toaster. We're going to optimize the use of that constrained resource, so we should try to produce products with the highest contribution margin per unit on that constrained resource. And then what we're going to try to do is to focus on loosening that constraint and breaking the constraint. And so what did Subway do in that case? They bought more equipment. You could also do some training, okay? But there's several options here on how to break that constraint, okay? And then, of course, this is a continuous improvement process idea, so then we would go back and identify some new binding constraints and try to loosen those. So when we talk over here about our theory constraints with respect to inspections and also batch sizes, so again, this is giving me some issues. Sorry, I'm going to just exit and come back in, okay? Doesn't like it when I move around too much sometimes. There we go. So whenever possible, we should have our inspections should take place before work is transferred to that department that has that constrained resource. That way, the valuable time of the constrained department won't be working on defective items. And that just makes intuitive sense to me. When you think about batch sizes, if the production process is a binding constraint, then it might be better to have a large batch size. There are some production processes, such as setting up equipment, that you would have to do regardless of the number of products that you make. If you make one product, you might have to set up equipment, versus if you make 50, you might still have to set up the same equipment. So in that case, try to do it in larger batches so you can minimize the setup cost per product. Okay? That's kind of like what this is talking about right over here. So let's go on to do our problem right over here, which is our product mix decisions under capacity constraint. Okay? So we look. Let me just catch up in my own notes right over here. Our company has two products, X and Y. The current constraint is machine N34. We have our data on the products X and Y right over here. Well, we have a selling price per unit and then variable cost per unit. Let's not worry about the CM ratio. So our contribution margin, of course, would be 24. 60 minus the 36 over here, it's going to be 15. The current demand per week is 2,000 units to make. Our customers want 2,000 units of product X, and they want 2,200 units of product Y. Each unit of X takes 1 minute. Each unit of Y takes 30 seconds. So if we were to think about it, how many total minutes do we need to make all of X and all of Y? Well, we need 2,000 minutes here, and we need 1,100 minutes here. So add the two together. means we need 3,100 minutes to satisfy the total demand for products X and Y. Well, here's the problem. Machine N34 is only available for 2,400 minutes per week, which is not enough to satisfy the demand to make both products X and Y. So the question becomes, which one should we make first, product X or product Y? Well, you might be looking up here and say, well, we should make product X because it has a higher contribution margin. Well, you're on the right track, but really what we want to do, if you recall from the prior page and what we were just talking about, is we want to emphasize the product that has the highest contribution margin per unit of the constrained resource. So in that case, we want to emphasize the product that gives us the most contribution margin per minute on this machine. So we're going to go through and calculate that. So if we look over here, we have our contribution margin per unit is 24. It's 15 for Y. And how long does it take us to make 1 unit of X? It takes us 1 minute. So how much contribution margin do we get for product X on each minute of the machine? $24. Over here with Y, it takes us 0.5 minutes or 30 seconds. So in that case, I would get $30 of contribution margin per minute for product Y on the machine, because I get 15 every 30 seconds. So that means I can make 2 products per minute, which is 2 times 15 gives me the 30, and so that's $30 per minute for product Y on machine N34. So which one should we emphasize? We should emphasize Y. Okay, so now what we're going to do is we're going to go ahead, and I say that up here, which product should be emphasized? It should be Y. So now what we're going to do is we're going to go ahead and allocate the time on machine N34 and basically do a production schedule. So we look over here, the total time, we have 2,400 minutes, right? And we say total time in production we want to make are 2,200 units of Y. That's our demand. And time required to process, it's 30 seconds. So I'm just going to multiply times 0.5, which means we need 1,100 minutes. Which means how much time do we have available to process product X, which means we have our 1,300 minutes left over. Okay? And then time required to process 1 unit of X is 1 minute. So how many units can we make? We can make 1,300 units. So we will make 2,200 units of Y, 1,300 units of X. And then with that, we can go through and calculate out the total contribution margin. 1,300 units of X, 2,200 units of Y, $24 per unit, $15 per unit. That gives us our 31,200 here, our 33,000 right over here, which means our total contribution margin would be $64,200, and this would be the optimal contribution margin. Because what are we trying to do? We're trying to maximize the contribution margin per minute on this machine. And so that gets back to the whole idea is that you want to choose those products or choose the part-time job that maximizes the contribution margin per unit of the constrained resource. In the context of the part-time job that I talked about earlier, you choose the part-time job, and that gives you a higher wage per hour, and by doing that, you're maximizing your use of your own constrained resource, which is your time. Okay? So I do have some additional problems here on pages 24 and 25. These page numbers 2 and 3 and numbers 4 and 5 on page 25 are both CMA review questions. Okay? And then what I also have is some additional problems on pages 26 through 28. I have posted spreadsheets up on Canvas detailing how to do those problems. Please do those extra problems and check your work against the spreadsheets, and the spreadsheets go over the problems in quite good detail. And please let me know if you have any questions. This ends the lecture video series for Chapter 7. Thank you so much.